Today we're going to take a look at strings in a lot more detail and see how they really work. So a string is really just an array of characters. Here I've declared one called string 1 that holds up to 24 characters plus a string terminator. I also declared string 2 to be an array of the same size. This idea of a string terminator is a special character which we represent as a \0, and we'll look at it in a moment, that indicates where the string ends. Because we declare an array of size 25, it doesn't mean that it necessarily has that entire amount of space filled with characters. It means it can contain up to that size as a maximum. But it might contain something considerably less. So they use the string terminator as a special character to mark the end of a string. Now let's take a look at how we can manually build a string. We can say string 1 sub 0 equals D, where it's a single character represented in single quotes. Similarly, we can set sub 1 to be O, sub 2 to be G, and sub 3 to be the string terminator, quote, \0, quote. And that will put the word dog in with the string terminator at the end. Now that's a 25-membered array. It's certainly not full by any means, but we only need one word, which is dog, and we don't have to use the rest of it. What's the rest got in it? Who knows? Whatever was left in memory the last time it was used. But the thing is, it doesn't matter because we're not going to look beyond that string terminator. And as long as we don't look beyond the end of it, we don't really care what's there. Now, there's a couple ways we can print these out. First, I want to show how you would do it absolutely manually. And that's what I'm doing right here. I've got a for loop, and it's going to say for I equals 0, while string sub I is not the string terminator, and it's going to do an I++, and then for every one of those, it's going to use %C, which is a format code for a single character, and it's going to print string sub I. So that's going to loop over all of the members of a string as long as it doesn't hit the string terminator, and it's going to print them out. That's one way to print a string. The second way is to use the %S format code. So I print a new line there just to separate it. Then I'm going to use %S down here and say my pet is a %S, and it's going to print out my pet is a dog. Now, whether I want to do this or do something like the manual version up there is entirely up to you. After you see how that works, most people are going to switch to using %S because it's a lot easier. But it is very illustrative to have a look at that because it really spells out exactly how a string is built in memory. It really is a single series of characters with a \0 as a terminating character. And you can go through it with a for loop and print out every one of those characters one by one, and it will work perfectly. Now, the other thing is, what happens if the very first member of the string is a string terminator? So if I take str1 sub 0 and set it to be the string terminator, and I print out my pet is a, it's going to print absolutely nothing because now there is no content in that string. It is a 0-length string or a null or empty string. I can actually run this and you'll see some of this working. So there's where we say my pet is a dog. My pet is a, and it didn't print anything because we set it to be a null string. Okay. Now, We looked at string handling functions, the built-in string handling functions previously, but a lot of this can be done manually. I'm not saying you want to do it manually, but I'm showing you this to show you how strings actually work and how they're stored inside the computer. So let's do a string copy of my dog is a big into string 1. And then I print that out just to show that it's there and it says my dog is big. Okay. Now we can count the number of characters in this fairly easily. We can use a for loop and we can set for I equals 0, string 1 sub I is not the string terminator, I++, followed by a simple semicolon. Because we don't have to do anything, all we're going to do is increment I every time we see a member of a string which is not the string terminator. So it'll go count all the characters in I until it hits the string terminator and then stop counting. So at that point we can print out %s, which is our string, has %d characters, and print out string 1 and I, which is what we used to count the number of characters. Most people would never do this because they would use strlen, the string length function built in, to do the same thing. But this is how you can actually do it by yourself. And it gives you an insight into how strings really are built. Another thing we can do is we can concatenate one string onto the end of another. And so what we would do is I'm going to copy into string 2 the words "and hungry." And I want to put that on the end of string 1, which, as you remember, said my dog is big, and now I'm going to add the words "and hungry." So I start out with this for loop, and I have to find where is the end of my dog is big in string 1. In order to do that, I set I equals 0 while string 1 sub I is not the string terminator, I++, and that will leave I at the subscript where it found the string terminator. Okay, at that point, I set a second for loop. J is going to go starting at 0. It is going to continue while string 2 sub j is not the string terminator. Every time through, it's going to increment both I and j, and it says string 1 sub I, and that was pointing to the place where the string terminator was in string 1, equals string 2 sub j. So it's going to copy the first member of string 2 right over the string terminator, and then the second member of string 2 onto the character right after that, and slowly copy them one by one until it hits the string terminator in string 2. At that point, string 1 now contains its original value with string 2 added on to the end of it. And all we have to do is now in the ith position of string 1, because that's what we were using to point into string 1 to tell it where to put characters, I was increased 1 more, and we put a string terminator on the end of it. And now we've actually done a complete manual string cat. So you probably will never write a string cat by yourself, but this is the set of operations you would do if you were doing it. And it shows that you can actually build strings up, put your own string terminators on it, and it gives you an insight into exactly how strings actually work. Let's just run this one more time. And you see my dog is big and has 13 characters. My dog is big and hungry is the result of actually doing the string cat manually. So that's how strings are built internally. And you can not only use the string handling functions to work with them, but you can actually manipulate them by hand with your own code if you want to do so.